Hello and good day. It's another day for us to learn something about psychological statistics. In this particular lesson, we will be learning about group frequency distributions. So let's begin. Previously, we learned about simple frequency distribution, and as the name implies, it is simple. But unfortunately, measurements on an interval or ratio scale usually result in too many different values for a simple frequency distribution to be helpful. Just like the examples that we had with the quiz course, it was particularly convenient because there were only about 8 different values. But what if in our table example this time has a data set of 0 to 100, and these are the midterm exam grades of your students, and they are about 25 scores. Now, if we put all of these scores in a simple frequency distribution, we would have to include all of the values from 98 down to 64, which means that many potential scores would have a frequency of 0. And by just simply looking at that array, you may not actually see that it could also be useful. We are also reminded that when we use this simple frequency distribution in this particular example, the problem, of course, is that the simple frequency distribution has too many different values. And the solution to this problem is to group the possible scores or the possible score values into equal sized ranges, which we also call class intervals. So from the dataset that you are seeing on the upper table, we are now grouping these possible scores into class intervals, and you may refer these class intervals on the left or lower left table. So as you can see, we have class intervals that start from 95 to 99, and the lower class intervals include 90 to 94, 85 to 89, and so on and so forth. And just like our simple frequency distribution table, our grouped frequency distributions also show group frequency distribution, which basically refer to the frequency for each class interval. So like for example, we have a class interval of 95 to 99, and it is also represented by a group frequency of 2, meaning the scores between 95 or starting at 95 to 99, two values were actually recorded. And if you would try to look into the data set, these are scores 98 and 96. The class interval 90 to 94 has a group frequency distribution of 3. 85 to 89 has a group frequency distribution of 8, and so on and so forth. As you may also notice, this grouped frequency distribution becomes even more informative when scores are being grouped this way than using a simple frequency distribution. As an example, in describing the construction of a grouped frequency distribution, we may actually focus on just one class interval in this example table that we have. So let's try to look into the class interval of 80 to 84. The interval is defined by its apparent limits. So like in a score of 80, we would know that 80 is the lower apparent limit of this class interval, and 84 is the upper apparent limit. Now we should be reminded that If the variable is thought of as continuous, meaning to say that variable of interest continues to change, these apparent limits that we are talking about are not the real limits, especially with the class interval. For instance, the score values from 64 to 98 represented the heights of 1 year old infants in centimeters. Any fractional value would be possible. So, like in particular, any height above 79.5 centimeters would be rounded off to 80 centimeters and included in the interval of 80 to 84. And similarly, any height below 84.5 centimeters would be rounded to 84 and also could be included in the interval of 80 to 84. Therefore, the real limits of the class interval are 79.5 and 84.5, which is the upper real limit. Because in general, the real limits are just half a unit above or below the apparent limits, whatever the unit of measurement happens to be.